Stanford University.
All right, well, welcome to Stanford CS193P. This is spring of 2016 version. And today I'm going to give you a real quick explanation of what this class is to make sure you're in the right place. I'm going to talk about prerequisites because it's super important to be successful in this class to have the prerequisites. Then I'm just going to give the briefest overview of what iOS is. Most of you know because you have iPhones or iPads or something like that, so I'm not going to waste a lot of time talking about that. And then finally, I'm going to dive right into a big demo that's going to build our first application. Because I really don't believe in wasting a lot of time with overhead. We're just going to dive right in and start learning how to do this stuff. Okay, we only have 10 weeks to learn iOS. That's a short amount of time for it. It is a very powerful system. So we're going to have to really go at breakneck speed. So what we learn in this class, you're going to learn to build cool apps, all right? iOS apps are cool. Why are they cool? Well, they're cool because they sit in your pocket and you can bring it out and show your friends. They're cool because they're really easy to distribute. If you build an app, you can put it on the App Store. It's almost no work. Boom, ship it out to your customers. And also, it's a very vibrant community, all right? A lot of people doing iOS development, and they're very excited about it. And also, the apps that you build have animation, a lot of really cool interactions with users, so they're fun apps to build. Okay, so you probably know all that. That's why you're here. Another thing you're going to learn, though, and you're going to get out of this class is real-life object-oriented programming. iOS is entirely object-oriented in its design. All the writing of code you have to do is object-oriented programming. And you're really going to get the experience of building a real-world thing using object-oriented programming, which is a great programming paradigm. And some of the things you're going to learn, for example, using object-oriented programming, object-oriented databases. We're going to do graphics with object-oriented programming. Obviously, going to be some multimedia stuff, multi-threading, animation, networking, all kinds of stuff that you're learning in your other computer science classes. You're going to do for real life here in this class. So that's a really good, it's kind of a good synthesis class, a practical synthesis class for all that stuff. The prerequisites are really important in this class. The main one is object-oriented programming. I really don't have time in 10 weeks to take the time to teach you object-oriented programming first, so you really need to know that coming in. So this, in terms of Stanford's prerequisites, that means CS106A and B or CS106X. That's absolutely required. Okay, so you get some Java experience in there, a little bit of object-oriented, and then really important to take some class where you're going to do a lot of programming. Okay, like CS107. Which is not hugely object-oriented, but it's a lot of programming. CS108, which is an awesome prerequisite for this class. Okay, that's basically object-oriented programming. So if you've taken CS108, you're going to be well prepared for this class. CS110, again, not really object-oriented per se, but there's a lot of coding in there. You know, preferably you've taken some other CS classes. You've written a lot of code because, let me warn you, this class is a lot of coding. All your assignments are all coding. You're going to write a ton of code in this class. So if you're not comfortable writing a ton of code, then this class is going to be a lot of work for you. You're going to find it, maybe you'll be a little underwater, okay? So be prepared for a lot of coding. When it comes to object-oriented programming, you should know all these terms like the back of your hand. You shouldn't be looking at those and going, what? What's that? Super class? I don't get it, okay? You should not even be here, okay? Go take these other classes and then come back. This is an upper level CS course. This is not 106 or 107, okay? It's the next level up. So if you haven't written a fairly sophisticated app before, okay, then you're going to find out, whoa, this is a lot of work, okay? So that's the prerequisites. Make sure you're prepared for this class. And if you're not, just go take those classes and come back. All right, so what's in iOS? You all know what's in iOS from a user standpoint. I'm sure you've all used iOS. So what's kind of under the covers? Right? What are the programming APIs? Everyone know what the word API means. That's basically programming interface. It's the functions and methods and classes that we use to make an iOS app work. So what are those APIs that we use? Well, they're huge. Okay, there's so much of it I can barely even summarize it here, but I'm going to summarize it by dividing it into 4 layers. Okay, the core OS, which is kind of near the hardware, all the way up to Cocoa Touch, which is near the user. Okay, and then there's some layers in between. So let's talk about these layers. Let's start down at the bottom there, the hardware. So people don't really realize this, but an iPhone is running Unix. Okay, there's basically a version of Unix running on it. So it has full multitasking, Unix file system, everything in there. And you get the power of that when you build iOS apps. Okay? And that includes all these things here. Now, there are some things at this Unix layer that are specific to a mobile device, like power management is really important, keychain access to make sure that the people are not accessing things on the phone that they shouldn't, etc. But this is basically Unix in all its glory down at this low level. Next, there's a core services layer. Because we want to program in object-oriented programming as much as possible, there is a layer which is written in object-oriented language on top of Unix, so you can get at things like networking and multi-threading and network or preferences and SQL for databases. You can get at these things using object-oriented APIs. So this is kind of an object-oriented layer on top of the core services. Okay, but there's no UI in this layer. Okay, this is kind of base layer. Now the next layer, super important. Ironically, I don't have a lot of time to talk about this in this class. I'll kind of let you know it's there, but it'll be something you'll have to dive into depending on what you want to do. But that's multimedia. So this is video, all kinds of different audio frameworks. And then, of course, still pictures like JPEGs, things like that. And drawing, okay, the Quartz API for drawing in 2D. OpenGL for drawing in 3D. So there's a lot of stuff here. Okay, we obviously don't have time in 10 weeks to teach you OpenGL. You're going to have to learn that in a graphics class, but you'll be able to use it here. Okay, and then at the top layer, this is where we're going to spend most of our time, is Cocoa Touch. Okay, it is object-oriented API for building user interfaces. Okay? And these user interfaces are not just buttons and sliders on the screen, but things like what to do when you shake your phone, or using the orientation of the phone as input, for example. Okay? It also includes animation, because in iOS, a lot of the apps, there's a lot of animation going on. It's just part of the way it's built. And a lot of the stuff at this level is really high level. Like there are objects that basically let you put an entire Safari browser in a rectangle inside your app. Okay, just one object, you just drag it in, boom, you got it. All you have to do, maybe wire up the back button, and you're ready to go. Same thing with maps. You've seen the whole map, 3D maps and all that stuff. Again, one thing, you drag it in, now you've got full map functionality in your application. So this is super powerful objects. Again, in 10 weeks, I can only show you the basics of this. Hopefully, the things I've chosen to teach you will have paradigms for using them that you can apply to the things I don't have time to teach you. Okay? So I'm going to try and teach you the basics of how to make it all work in a way that lets you go out and learn new things quite straightforwardly. Okay? So that's basically what's in iOS in 3 minutes or less. The components of the platform that we're going to be developing on are as follows. First, there's some tools. Really, Xcode 7 is 99% of what you're going to be using in this class. Okay? It's your editor, your debugger, source code management, everything is in Xcode 7. It's kind of a one-stop shop. There is an extra thing there, instruments, which kind of plugs in with Xcode 7 for doing things like performance measurement, things like that. But basically, we're going to be in Xcode 7. Okay? That's where we're going to be doing all our work. Languages, there's actually 2 languages you can develop for iOS. We're going to teach you the more modern one, which is called Swift. Okay? But there's another one called Objective-C. I'm not really going to talk about Objective-C in this class, or at least not primarily in lecture. So you will have to learn a new language. I'm sure none of you know Swift, or if you do, it's because you already know iOS. Swift will be a new language you have to learn. I'll spend the first 2 weeks really trying to give you rocket speed learning of this new language. Then there's a lot of frameworks, okay? Like Foundation and UIKit, which is the kind of that base core services stuff and the UI stuff. But there's also Core Data and Core Motion and MapKit for all these things like the gyro and the accelerometer and the object-oriented database and all that. So there's a lot of frameworks, and we'll cover as many of them as we can. And really, just as important of all of these things, there's a design strategy or a design methodology, okay, for iOS called MVC. It's used on other platforms as well. How many people here have programmed before in an MVC type environment? See, so about half of you. Now, I'm going to, since it's only half of you, I will spend Wednesday, the start of the lecture, explaining MVC, okay? What MVC is, how it applies in iOS development. But it's very important to know, okay? It's a very important thing to know, and I'm even going to mention it a little bit in my demo today, okay? And I'll just give you this, like the 10-second overview of it. Because I can't really do anything, I can't show you any demo without talking about MVC. It's that important. Okay? So this next slide here is kind of giving you a summary of what I'm going to show you in the demo today. You don't need to read this slide now. My slides will be posted for you, so you'll always be able to go back. This is a kind of slide you go back and look at later to make sure, oh yeah, did I understand that in the demo, etc. Also, as I'm doing the demo, you'll have the video of it, okay? You'll have a video of this demo, so you don't need to furiously take notes or try to follow along to understand what I'm doing, okay? You can watch it at your leisure later, okay? All right, so I'm not going to get back to my slides before, after the demo, so let me tell you what's coming up, okay, and then the rest of this is going to be the demo. Today, I have assigned, and it's on Piazza already, reading assignment number 1. Okay, the reading assignments in this class are all learning Swift. You're going to have 3 readings assignments, and all the 3 of them are going to basically take you through the entire Swift language guide, okay? So that's what the reading assignments are all about. On Wednesday, I'm going to continue the demo that I'm doing today. I'm going to talk about MVC, as I said, and then programming assignment number 1 will go out. Okay? And that's going to be due 1 week later, okay, before lecture the next Wednesday. All right? On Friday, we have an optional section, room and time to be determined, probably around 1 o'clock. I'm not sure where. This Friday's top, and each Friday, sometimes we'll have these sections, sometimes not, and it's optional. You don't have to show up if you don't want to, but it's going to be pretty valuable information. This Friday is how to use the debugger, which, as you can imagine, pretty valuable. Next Monday, next week in general, we will be doing more of the same, of getting started here with Swift and Xcode 7. Your reading assignment from today is going to be due on Monday, and then you'll have reading assignment 2 go out, which will be due the next Monday. So the reading assignments for the first 3 weeks are overlapping the programming assignments. The first 2 programming assignments are quite easy, so it won't be a problem where you're really overloaded. Starting with assignment number 3, it gets quite a bit steeper. Okay? Question?
The programming assignments, they ask you to solve specific tasks. Are there any ones that are more open-ended?
Yeah, so the question is, do the programming assignments ask you to solve a specific task, or are they kind of open-ended? And the answer is, the programming assignments have very specific required tasks that you must do. You can do them any way you want, but you must satisfy the required tasks. As far as open-ended is, you're going to have a final project, 3 weeks, that's completely open-ended. You get to choose entirely what you're going to do, completely on your own, okay? If you read the document that's on Piazza, it explains all that, okay? So for those of you who arrived late, read that document, get on Piazza, read it, stay on Piazza. It's all about Piazza in this class in terms of communication, okay? So get on there, okay? All right, that's it. I'm going to dive right into this demo right here. We're going to start by launching Xcode. So Xcode is free. You just go to the Mac App Store and download it. And when you launch it, you're going to get this splash screen is going to appear right here. Let's hide these other things. So here's Xcode. This splash screen has a list of all the projects that you've been working on. So right now we have none because it's the start of the quarter. But you'll have, each week you're going to have more and more projects piling up in this side. And then these 3 choices are the 3 ways to kind of get into Xcode. 1, here, Playground. That's basically gives you the ability to write iOS apps and play with Xcode without building an app. Okay, so you can call APIs, put things on screen, draw things, etc. It's kind of a playground for playing around with iOS. We really won't be using that much in this app, but in this class, in my demos. But you can certainly, you're welcome to use them as you're playing around with Xcode. It's kind of a fun environment. Down at the bottom here, you can check out an existing Xcode project, iOS project, that is in source code management. Okay, now we're going to talk about source code management probably at a Friday section in this quarter, but not right at the beginning of the class. But source code management is basically a way that you can check your code in and out of like a database, okay, so that you can work with a team, each make changes, merge your changes, all that stuff. So here is where you would check out your project to work on. And this middle one is to create a new Xcode project, a new Xcode app. And that's what we're going to do right now, okay? We're going to create from scratch a new app. Most of my demos involve creating an application from scratch, okay? Just because I think it's easier for you to learn if there's no magic behind the scenes where things are appearing out of nowhere. So we're going to start from scratch and go from there each time. All right, so I'm going to click on this. You can see it wants to create an app for me, so it's going to ask me some questions. First, it wants to know what kind of app I want to build, and we want to build an iOS application. So make sure you click iOS application here, not Watch app or Apple TV app or an OS X app. Okay, we don't want any of that. We want iOS application. And inside there, we have some choices of the kind of iOS app we want to build, like a game or this master detail, which is usually for browsing a database. We're almost always going to choose this one, single view application. The view there is kind of referring to the view in MVC, Model View Controller, that design paradigm. But this is the most basic template, and it gives us the least amount of code to start with, which is what we want, because we're learning, so we want to write the code. We don't want it to write any code for us. So we're going to pick single view template there. Now it wants to know a few things about our app, what the name of our app is, etc. The app we're going to build today is a calculator, and it's going to look quite a bit like this calculator. Not exactly the same, but similar to this calculator. This is the basic calculator that comes with Mac OS. It's going to look like this. It's going to have some keypads, it's going to have some operations, it's going to have a little display in here. Basically a calculator, so I'm going to call my app Calculator. So that's the name of this app. When I look at it on my phone, it's going to say Calculator is the name of it, okay? This organization name can be anything you want. It's basically going to appear in the copyright of your code, okay? When you write code at the top, it's going to say copyright, whatever you put here, put whatever you want, your name or whatever. This, however, wants to uniquely identify you, okay, as a developer. And a good way to do it is this reverse DNS notation here, edu.stanford.cs193p, and then instead of putting instructor, put your SUNet ID, because no one else has that. This would uniquely identify you in the universe. No one else is going to have that organization identifier. And then it builds a unique identifier from the app by combining these two things. Okay? You get to choose the language you want to program in here. It actually doesn't matter what you choose here. This is just going to be the language that the initial template is going to give you starts out in. You can freely mix Objective-C and Swift when you're building iOS apps. Okay? Back and forth. You don't have to pick one and be stuck with it. We're going to do all our programming in this class in Swift, however. Then this is whether we want to build an iPhone-only calculator, an iPad-only calculator, or a universal calculator that will work on either iPad or iPhone. Okay? And we're going to go universal. Even though the first 2 weeks we're going to be focusing on iPhone only, in the third week we'll expand our calculator to work on an iPad as well. Here we're not going to be using databases yet. That'll be about week 6. And we will be talking about testing later in the quarter, probably in a Friday section again, but we're not doing it now, so you can leave these unchecked. All right, so now I hit next and it says, where do you want to put this project? I'm going to put it in my home directory in a folder called Developer, and I highly recommend you do the same. Okay? Home directory Developer, so all your apps will start piling up in here. Here's the source control thing I was talking about. We're not going to do this at the beginning, so I'm going to leave this unchecked. All right, so we hit create, and it creates our first app. Now, it's actually created these 6 files over here on the side, and over the course of the quarter, I'll show you what all 6 of these are about. Today, we're only going to focus on 2 of them. And how many of you have used Xcode before for any class or anything? Okay, so about a third of you. So let me explain a little bit about Xcode's UI and what it looks like. You see this area on the left, this blue area? That's called the Navigator, and it's basically for navigating your project, and you can do it in different ways. This is the Project Navigator that we see right here, and it's basically showing you your files. You can arrange them in folders and stuff, but it's basically the files in your app. But you can navigate by searching. Okay? You can type some search text in here, search for it in your app. You can navigate all your breakpoints if you're debugging. You can go back and look at all your old builds to see any errors or warnings you have. Okay? Even if you fixed it, you can go back and look at them. So the Navigator is kind of how you keep track of what's going on in your app. On the right-hand side here, we have the Utilities area, which is actually 2 windows. See, it's split, top and bottom here. Okay? The top part is essentially an inspector. It's going to let you analyze and change attributes of whatever's selected in this main window. Right now we don't have anything selected, so it's not showing anything. And this bottom is essentially like a palette. Okay, you're going to be an artist building your app, okay? And you're going to need things like buttons and web views and things like that to build your app, and you're going to be finding them all and pulling them all out of here. So it's your palette, your artist palette as you build things, okay? You can show and hide these two side panels with these buttons up here. I will tend to not do command keys except for like copy and paste so that you can see what's going on. But there are tons of command keys in Xcode, and if you go to Xcode Preferences and look under key bindings right here, you'll see all of them, and there's tons and tons and tons, and you can even change them, of course, if you don't like them, but it has a lot of commands. All right, so I'll try to avoid using those command keys. So you can hide those with these things, so you have hidden both sides, right? Okay, and you can kind of manage your screen real estate. Now I have a very low resolution screen here, so I have to manage my real estate quite efficiently. If you have a higher resolution screen, then you would obviously not be doing as much hiding and showing of these things. So if we look at the navigator, what's selected right now? It's the project itself. At the very top level, this blue bar is selecting the project. So we're actually seeing the project, okay, the kind of settings of the project in the main window here, this main window. And here's some of them here, right? Some of these we set on that first page, like the bundle identifier, and whether it was universal or iPad and iPhone, etc. But there's plenty more settings over here. We'll get to most of those settings as the quarter goes by. The only setting that's important for you to know now is this team setting. You see where it says Team None? You're going to want to be able to write your app and have it run on a device. Okay? It has a simulator, which I'm going to use today, but you also want to be able to run on a device. And to do that, you need to register an Apple ID. So here I already have mine, this CS193P instructor, but you're going to go down here to add an account, and you're going to give an Apple ID and password. Any Apple ID will do. You don't have to join any program or anything, just any Apple ID will work here. And you put the ID and password in, and then you're going to select it here, and then it's going to appear here like this. Okay? Now, when you have a team selected, now you can plug a device in, and you're going to get this warning here, no provisioning profiles found. And you just click Fix Issue right there. You have to be connected to the network at the time. All right? Fix Issue, and it'll fix that. It'll basically get the ID of your device, register it with you as the developer, and off you go. Okay? So you'll need to do that. You only really need to do that when it comes to running on a device. When we're running in the simulator, we're not going to need to do that, but you might as well get this started now. Okay? Now, what about these other files over here in the navigator that it made, these 6 files? Well, like I said, we're not going to talk about all of them. This one, for example, assets.xc assets, that's all your media assets. So that's images, sounds, icons, things like that. Here, for example, is the app icon, which I haven't set, so all these are all blank. So we're not really going to talk about that today, but we'll eventually talk about it. And in fact, not only am I not going to talk about this XC assets thing right here, but I'm also not going to talk about this app delegate or the launch screen or the info.p list. Okay? So I'm going to select all those and right-click on them and choose New Group from Selection and put them all in a folder, okay? Which I'm going to call Supporting Files. Because that's what they are, really. They're kind of files to support my app. You see, they're still there. I just kind of got them out of the way so we can focus on these 2 files, which is the most important thing to our demo today. Okay? Now, what are these 2 files? Now is where I have to talk about this MVC thing. Okay? So MVC stands for Model View Controller. Okay? Model View Controller is a way of kind of dividing up all the classes in our object-oriented app into 3 different groups: the model group, the view group, and the controller group. Okay, what are those 3 groups? The model group is what our program does that's UI independent. So for a calculator, it's going to be all the calculating, the things that actually does the calculations, right? That's UI independent. That's going to be our model. Okay? The view is the user interface that the user interacts with. So for the calculator, it's the buttons and the display and all that stuff. That is the view. Okay? Usually that's made of generic user interface elements like buttons and things like that. And then there's the controller. The controller is the glue between the model and the view. Okay? It's the thing that listens to what's happening in the UI, makes decisions, updates the model. If something changes in the model, maybe it changes the UI. Okay? Back and forth. It's really where the interface, the logic of our entire app really lives in our controller. Okay? So this file right here, viewcontroller.swift, that is our controller. Okay? Our app is only has one MVC. Okay? which is the calculator, MVC, and this is its controller, okay, the C of MVC. Now, here is your first look at Swift. I'm going to explain this real briefly. You can see that Xcode has thrown in a couple of methods for me. Everyone knows what a method is. They're so exciting that I'm going to delete them. Okay, that's because I don't want to distract you with a lot of random code, so we're going to keep down just to the minimal code we're going to use. We will be using those methods later in the course. Those are part of what's called the view controller lifecycle, but we don't need it for our calculator app. So let's look at what we have left here. This import is kind of like an include in other languages or import in other languages, but this is not a file. This is a module. And in Swift, you can group a whole bunch of classes together, and that's called a module. And when you import a module, all those classes will be visible, if they're public classes, to whatever's using it. So here, UIKit has all the user interface things, buttons, text fields, all that stuff, okay, is in there. And so since we're building a UI app here, a calculator, we're going to import UIKit, and you're almost always going to import UIKit. Okay? Now in our model, where it's UI independent, we're going to probably be importing Foundation. Foundation is that core services thing, okay? Because we might be doing networking and databasing in our model, but we're not doing buttons and stuff. So those are the two main things you import. Okay? Here is the definition, or declaration really, of a class. Okay? In Swift is what it looks like. You got the class keyword. This is the name of the class, view controller. Now this is a pretty bad name, okay, because it's very generic, view controller. Probably be better called calculator controller or calculator view controller. I'm not going to show you how to rename that now, but I will show you next week. But this is the name of our controller class. This :UI view controller means that UI view controller is the class our controller inherits from. This is object-oriented programming. We have inheritance. This is the inheritance. Single inheritance in Swift, okay? All controllers, all MVC controllers must inherit from UI view controller, either directly or indirectly from UI view controller, okay? And then we have curly brace here. Inside those curly braces goes all of our properties and methods, okay? Properties are like instance variables. Everyone knows what an instance variable is, right? So our property, we call them properties in Swift. They're very powerful in Swift, the instance variables. They can have behavior associated with them and things like that. But all that goes inside these curly braces, okay? So that's your intro to Swift. What about this other file over here, main.storyboard? What's that? That's the V for view of our MVC. That's the graphical representation of our calculator. So let's click on that and see what it looks like. Right now, it's just a big square, big empty square here. And I can zoom in and out, so I'll zoom to 50%. See? Here's our UI. Now, it's kind of interesting this UI is square, okay? How many iOS products are square? 0, right? None of them are. They're all rectangular, okay? So they're either landscape or portrait, iPads, whatever. None of them are square. And so how are we building our UI in a square UI? Well, we're doing that to remind us that we want to build our UI so that it stretches and expands and move things around so that it'll fit in any shape. Okay? So we're going to build one UI. It's going to work on iPad, iPhone, tall iPhones, short iPhones, high resolution ones, low resolution, all of them from this one UI. And this is square to remind us that. If this were vertical rectangle, probably our UI would look great in portrait, but maybe not so good in landscape. This way, square, it's constantly reminding us that we have to build this flexible UI. Now today, I'm not going to do that. I'm going to build the UI all up in the upper left corner right here so that it looks good in any, or not looks good, but at least shows up in any shape. But on Wednesday, we'll put in the flexibility to make it do what it needs to do. Okay? So how do we build this UI? We build our entire UI graphically, okay, with the mouse. Okay? We do not write code to say put button here, put text field there. We just build it all graphically and wire it up with our mouse. And so we're just going to dive right into doing that. I'm building a calculator. Calculator needs some buttons, so let's start with a button. I told you that in this utilities window at the bottom, there's the palette of things you as an artist, and now we are UI artists here, are going to build our UI out of. And you can see there is, whoops, get the dock out of the way. There we go. Lots and lots of things that we can build our UI out of here, and we'll talk about actually most of these in the 10 weeks we have. But we're going to start about a quarter of the way down with this one right here, button, and I'm just going to pick this up and drag it out into my UI. Now when I do that, notice that these blue lines appear and disappear. The blue lines help you put something in a theoretical or conceptual place. Like this would be putting the button in the conceptual center of my UI. So if I'm in portrait, it's going to be centered in portrait. If I go to landscape, it'll move over and be in landscape. Do you understand what I'm saying? These blue lines allow us to put things in various places, and this is a big part of how we're going to make this flexible UI. But since I told you I'm not going to show you that until Wednesday, we're not going to do that. We're not going to use the blue lines, okay? But you'll see me using the blue lines on Wednesday quite a bit, and you'll want to always use the blue lines. The blue lines are super important to building this flexible, adaptable UI. All right, so we have our button right here. Now, we don't want it to say button on there. Okay, we want it to be one of the numbers, right? This is going to be part of our keypad. So I'm going to make this be my 5 button. And to change the text, you can just double click on it and change it. Okay, so I'm going to make it 5. You notice it also has these little handles around the edge. You can use those to resize it to whatever you want. So this is computer science class, so we'll make it be 64 by 64. Okay? Although it really doesn't matter what size I make this, because when it starts being flexible, it's going to start, resizing it to fit depending on what the environment. But anyway, we'll do that. Now, other things I want to change about this button, I don't do directly. I need to use this top half of the utilities window here, which is the inspector. Okay, now there's different kinds of inspectors along the top. You'll see here what's showing now is the attributes inspector. It is the attributes of whatever is selected. Here is the size inspector. So if I click that, for example, here's my 64 by 64, and I can edit it here as well. I could say 200 by 64. See how this got wide, right? We could go back to 64. Okay. I'm going to go back to and we'll talk about these other ones, the identity inspector and stuff later. But let's go back here to the attributes inspector. This is actually object-oriented. So here I can set the attributes of a button, because that's what's selected here. And also I can set the attributes of a control, which is buttons superclass. And then attributes of view, which is controls superclass. So this goes right up the hierarchy, of the inheritance hierarchy rather, and lets me set various things. For example, I want this 5 to be bigger. So I look here in the buttons attributes, and I see font, system font 15 point. Well, I'm going to click this and change this to be 30 point system font. Okay, that looks a lot better. And if I go back and look at this calculator, see how some of the buttons have a background, like gray or orange? I want that too. So I'm going to set the background of this to something. So I'm going to go down. That turns out to be something that button inherits from view. Right here, background. So I can set it by, using crayons, okay, or whatever. I can use sliders, or I can use maybe recently used ones, like here's light gray, okay. So I've set my nice little background here. So, you can go and edit these things and make them look however you want. What's interesting about what's going on here is there's no code generation step going to happen here. You're actually editing these objects live, okay, by changing things in the inspector. You're sending messages to this button to set the way it is. And then Xcode has a way to essentially freeze dry all the attributes. And it's object-oriented. In other words, the objects are participating in freeze drying themselves. And in fact, the whole mechanism of this part of Xcode, which we call interface builder, because we're building our user interface, is extensible. And you can put your own objects in here. Okay? Your own things they draw, custom drawing or whatever. And we'll show you all about that as the weeks go by. All right, so I have one button here. That's good. I could even run my app right now. So how do I run this application? You go up here to the top. You see where it says iPhone 6s Plus? This is actually a list of simulators that you can choose to run your app on. All right? So you could also run it on a device. If you connected a device and did that team thing I was talking about, you can run it on a device here. But I didn't connect a device, so I'm going to run it on an iPhone 6. Okay, so I just pick iPhone 6, and then I just press play right here. So we press play. It's going to bring up an iPhone simulator, okay, and the iPhone simulator is going to run this app. Now, this iPhone simulator that you see appearing right here, it's showing our app. This is more than just our app. This is actually a full simulator of the iPhone. And in fact, if I go hardware, home, that's like pressing the home button. You know the little round home button on your iPhone? Watch this. Press home and it goes to here. And I got settings, photo, calendar, Safari, other apps, etc. Okay, and here's my app. Mine's just an app. Calculator has no app icon, but there it is, and I can go back. Okay, so it's really simulating the device here. Now, what happens if I touch this button? Nothing. Okay, and that's because we haven't really taught our calculator app what to do when this button is touched. So let's go do that. Now, how are we going to do that? Remember I told you that the view here is kind of generic UI, buttons and sliders, and that there's a model which we don't have yet, okay? And then there's the controller. So the way that touching on buttons causes anything to happen is via the controller. So somehow we have to connect this button up to our controller. And in fact, what we want to do is, when we touch this button, we want to invoke a method in our controller object, right? Sounds nice and object-oriented. That's what we want to do. So how do we set that up? Okay? We're going to set that up by getting the controller and the view on screen at the same time. Okay? And then we're going to wire it up graphically with the mouse. So let's get them both on there at the same time. The way we do that is with this button right here, this little round circle, the assistant editor. This brings up the controller and the view on screen at the same time. Again, I have low resolution, so it's all kind of smashed. So let's close our navigator and close our utilities. Okay? And we can share this space however we want. Okay? So we have plenty of room for our code. And here's our controller. So now this is going to seem wacky, but it's actually really, really cool. Okay? The way that we hook up that button to call a method in our controller is by holding down the control key. Okay? I'm going to hold down the control key and drag from the button into my code. Okay? Now it really seems weird, but it's cool. Okay? So I can put it wherever I want in my class here. And when I let go, it's going to say, okay, what kind of connection do you want to make between this user interface object and your controller? And there's really two choices. One is called an outlet, which I'm going to talk about in a moment. And the other one is called an action. So an action is when you want something that happens in the UI to invoke a method in your controller. Okay? Exactly what we want here. That's what an action is. So here it's asking the name. It wants to know the name of the method. So here I'm touching a digit button, so I'm going to call this touch digit. Okay? So this is just the name of the method that is going to be created in my controller. Notice that my method can have arguments. You see down here where it says arguments? It could have no arguments, okay? Which is fine, right? If I don't want an argument, that'd be fine. It can have one argument, which is the sender. In other words, the button that is sending me this method. Okay? That's really valuable argument, okay? Especially in this case because I'm going to have a whole bunch of buttons. They're each going to be sending touch digit, and I want to know which one sent it to me. So the fact that it's going to pass itself as an argument to this method is great. The only problem is, if you see this type right here, any object, that's going to be the type of the object. It's this generic any object thing right here. We don't want that, okay? So when you're doing your homework, don't miss this step, okay? Change this from any object to UIButton. Because, of course, the thing sending us this message is a UIButton. It's unfortunate that this is not the default, but you must do this, okay? So this, I'm going to hit connect. This is just what event is causing this, a touch on the button that goes up inside the button's bounds, okay? So I'm going to hit connect right here, and it's going to write the code for a method. You're going to see your first Swift method. Here we go. Okay? This is your first Swift method. Now, this is actually not part of Swift. Okay? It's not part of this method. This is something Xcode puts in here so that this little round circle appears. You see that round circle right there? If I mouse over that round circle, you see how it shows me what thing in my view is hooked up to this method. You see? Okay, so that's what this is. So that's really not part of a Swift method. Okay, so this is all the Swift method. Okay, so what is Swift method syntax? Func. Okay, func means this is a function on a class. A method is essentially a function on a class, right? I suppose this could be called method. I mean, like the Breaking Bad version of it would be called meth, maybe. But func is good. Func is good because you can have global funcs also. Okay, you could have the same syntax outside of a class description, outside of these braces, and it will be a global function. And we're going to see some of those, like square root is a function I'm going to use when I add square root to my calculator. All right? So that's the keyword, just like class is the keyword for creating a class. Func is the keyword for adding a method. Touch digit is the name, obviously, of this method. Parentheses has the arguments. Okay, we only have one argument called sender of type UIButton. So that's what :UIButton means. Anytime you're defining a type of something in Swift, colon and the type after the name of the thing. Okay, and that's true for arguments to methods. It's also true for local variables, everything, colon and the type. Okay, now if we had more arguments, they would just be separated by comma, like other argument might be an int. Okay, so I put an int there, so this is another argument, second argument here. And I can have as many as I want, and they each have to have a keyword which describes what they are. If this had a return value, it looks like this. Returns string, okay, or returns double, okay, something like that. That's how return looks like. Okay, now I'm going to take a time out here from writing our calculator and just show you what it looks like to call a method. Okay, this is we're declaring the method. What if I wanted to call this method on myself? Okay, it would be recursive here because I'm inside touch digit, but I just want to show you the syntax for calling. Okay, so if I want to send something to myself, I use the keyword self, and then to send a message, just like Java, you press dot. Okay, the thing you want to send it to, dot, and then you type the name of the method or of the property. If you want to access an instance variable, exactly the same. The name of the property or the method that you want to access in that object. So here, I want to do touch digit. You're going to notice here that Xcode is helping me a lot as I type. It's giving me lists of things that I can choose that are likely. Here, touch digit, it's putting that on the top because that's the only method that is in my class. I inherit a lot of methods from my superclasses, but this is the only one in my class. And in fact, if I just press tab, it starts filling it out. I don't even have to type it, okay, because it knows that's what I want. Now, it takes two arguments. The first argument, you just put it in. So the first argument is a button, so maybe some button or something like that. Okay, some variable that would have to be a button. I don't have one, but that's what it would be. The second argument here, okay, and I'm just hitting tab to go to each argument, is an int. So let's say I put 5. Okay, so this is how I would call this thing. Now what's interesting about this is notice that this keyword is actually included. In other languages, this would look like this, right? You would just have the two arguments, sender and argument. But here in Swift, we put the explicit name of the argument here for readability and clarity, except for we don't do it with the first one. Okay? The first one we don't do. That's because usually the first one is implicit in the name. Okay? That's what. Now there is a way to make it so you have to do the first one for digit, but generally we don't. In other words, we don't type sender this, and in fact, it's wrong to type sender that.
Would that be an error?
Okay. It would be an error. It would not compile. Okay. So that's the syntax for sending, and you'll have to get used to putting these in for all the subsequent arguments besides the first. Okay. So let's get rid of all this stuff we added. So here's our touch digit. Let's just have touch digit print something out to the console. Okay, great thing to know for debugging and stuff like that. You do that with the method print, and I'm just going to say print touch digit. So it's going to print touch digit out to the console. Notice no semicolons on the end of lines or anything like that in Swift. The carriage return is the end of line. If you want to put two statements on the same line, you can use a semicolon in between, but generally the carriage return is the end of line. Okay, so we print touch digit here. Let's go ahead and run and see if that works. Okay, here's our simulator. Now, where is the console? It's going to appear magically at the bottom here as soon as something appears on the console. So here we go. Ready? 5. There it is. There's the console on here. 5 again. Okay, we got 2 of them. Okay, we press a whole bunch of times and get a whole bunch of them. Go back here, scroll around. This bottom area has the console on the right and your debugger output on the left. This is where, when we start doing debugging, you'll see it on the left. You can hide one or the other, like we could hide our debugger and just see our console here. Okay, so this is cool. This is great, except for we're going to have a lot of buttons, not just this one button, this 5. Okay, so let's go back to our UI. By the way, you can hide this thing by either dragging it down or pressing this button up here. Okay, just like you hide this thing with that, you hide with this with that. All right, So we'll stop. Now I want to make a whole keypad worth of buttons here. Instead of just having a 5, I want a whole bunch. So I'm going to do that with copy and paste. Copy, paste. Okay, make another one. Paste another one here. Okay, maybe this is our 4, 5, and 6. I can actually select all 3 and copy, paste. Okay, 1, 2, and 3. And maybe paste again. Go up here. 7, 8, 9. And we'll copy and paste one more to make our 0. Okay, so here's our nice little keypad right here. And now we can run. And we'll notice that all of these buttons are sending touch digit, you see? Okay, so they're all sending touch digit, which is good. That's kind of nice. We can also tell they're all sending it with this little circle. Watch what happens when I mouse over, you see? It's selecting them all to say they're all sending this. Okay? But we really want to know which one is sending it. Okay? So we're going to have to look at this sender argument to see which button is sending us this touch digit. Okay? So I'm going to create a local variable here. This is how you create a local variable, var, the name, which I'm going to call digit, and I'm going to set it equal to whatever I get from asking the sender what its title is. Okay? Now, how do I do that? Well, we know that we send a message to something by doing the object, right, sender, and a dot. Okay? Unfortunately, button has quite a few methods. Okay? I mean, probably hundreds. Okay? Because it's inheriting things from control and view and stuff like that. So this is pretty much a bummer trying to find out how to know what to get. So we need documentation here. We need some help. Okay? So the way to do that is you're going to hold down the Option key. Okay? I already showed you Control is an important key for dragging between your view and your thing. Now Option is an important key. And when you hold down Option, look what happens when you mouse over things. They get this dash blue underline going. And what that means is if you click on them, Xcode's going to tell you as much as it can about that thing. So let's click on UIButton. And when we do, we get this little window that has a complete description of UIButton in here. And really importantly, down at the bottom, it has a reference link. See this reference link? And if I click this, this is going to take me to the documentation for UIButton. So there we go. Here it is, UIButton. Here's all the methods and properties in UIButton. Here's all the description of it. And there is all kinds of text here that describes all the methods and how they work. Okay? Now, I need to find something about the title. So I could search here by just doing Command F to search, and I could search for title. But unfortunately, the title is mentioned a lot. See? So that's no good. So I can go over here to the summary of all the methods and properties. We can look here, getting dimensions. No, I don't want to do that. Configuring edge insets. We don't even know what that is yet. Getting the current state. That sounds pretty good. Getting current state. Let's see if we got button type. Okay, here's how I can get the buttons type. That's good. Current title. The current title displayed on the button. Victory. That's what we want. Okay, now when we find something in the documentation we want, you're going to see that there's a Swift explanation of it and an Objective-C explanation. So we're always going to be looking at the Swift version in this class. So what is this thing? Okay, this is not a method because it would say func right here. If this were a method on UIButton, it would have func. Instead, it has var. That means it's a property. So a property is like an instance variable. Okay? Now, this is an interesting property because it's got this little terminology in the end, which means it's read-only. So we can't set the button's title here with CurrentTitle. Turns out that's because there's another method up here called setTitleForState for setting the button's title. Because when you set the button's title, you want to set the title for what state it's in, highlighted, disabled, whatever. But luckily, there's a CurrentTitle here that just gets you the current title in whatever state the button's currently in. So that's why it says var instead of func. Here's the name of the property, CurrentTitle. Here is the type. I promised you that it was always colon and type. Now, the type of this is string? What? Maybe. Okay, we're going to suspend our disbelief here because that question mark actually means something. We're going to kind of hope that this is a string, but it's not going to be, but that's okay. Okay, we're going to try and assume it is, all right? So anyway, this is how we look things up in the documentation to see the way it works. Now, there's another way to do it, okay, which is even cooler. I type this dot. I want the title, so I'm just going to start typing title. Okay, I don't know there's a method called title. In fact, there isn't. But as soon as I start typing title, it shows me all the methods that start with title, all the methods that include title in the name, see? And all the methods that have T-I-T-L-E in the order, okay? And it gives it to you in the order you might expect, right? Title first. So this is kind of helping. You can search, basically, and when you do this, you would quickly see, ooh, current title, that looks like what I want. And you can double click here, actually, and it'll put it in there. Okay? So there's our current title. Now, instead of printing touch digit, we basically want to print which digit was touched here. So I'm going to say touched, we could say %s digit, comma digit. This is what it would look like in C, for example. Is everyone familiar with this printf-like format? Okay, good, because you can't do it in Swift. Okay, we don't do that in Swift. Instead, we do \, open parentheses, close parentheses, and then we can put anything we want in here. Okay, including digit. And we don't need this out here on the side. Okay, so this will be evaluated, converted to a string. Some things can't be converted to strings, but most things can. So you put that in there. Okay, if it can't, you'll get a warning. Okay. All right, so that's how we do that. So let's go ahead and see what's going on. But now, maybe we should start paying attention to our warnings. Okay, when you submit your homework, no warnings, please. Okay, no warnings. And certainly no errors. Those are red things. Those won't build. No warnings. So what is this warning? Let's take a look at this warning. You look at a warning by clicking on it. So I'm going to click on it. And it says here, variable digit was never mutated. Consider changing to let constant. Okay? What does that mean? Well, that means that instead of var here, it wants us to put let. Okay? And in fact, you should always do that. Anytime you declare a local variable, okay, or even a property that is initialized at the beginning and never changes, in other words, it's a constant, use let instead of var. Now, why do you want to do that? Two reasons, really. One, it helps people reading your code realize, oh, this thing's never going to change. I don't have to worry about it. It's just like a constant. And two, if that thing were, for example, an array or a dictionary, and you used let, that means nothing could be put into that dictionary or taken out, or into the array or taken out. Okay? So it's how you can create read-only arrays and dictionaries. Okay? So always use let when you are doing a constant. And in fact, notice that Xcode is saying, hey, if you click here, I'll fix it for you. Okay? So it says fix it, replace var with let. Sure. Okay? And it did it. Now our warning's gone. Okay? So let's run. See if this is working. We're crossing our fingers about that whole string question mark thing. All right, so here we go. Let's press 5. Oh, what the heck is going on down there? Okay, touched optional 5 digit. Okay, so what is this optional business? Okay, so here you all want to take a deep breath, clear your minds, and pay close attention. Okay, because this is a very important thing in Swift. It's ubiquitous throughout the entire iOS API. Okay, very cool feature, but it requires a little bit of getting used to in terms of its syntax. Okay. This is the feature of optionals. Okay? In Swift, there is a type called optional. It's a type like int or bool or anything else. String, dictionary, array, optional. Optional is just a type. This type can only have 2 values. One value is not set. Okay? That's expressed in Swift with the keyword nil, N-I-L. Nil only means this optional is not set. That's all it means in Swift. It doesn't mean it's 0. It doesn't mean a pointer that doesn't point anywhere like in other languages. Nil means an optional that's not set. The other state that an optional can be in is set. Okay? Now, if it's in the set state, it can have an associated value. Okay? An associated value, which can be of any other type. Okay? Actually, it could also be an optional. You can have an optional. But that associated value is just associated with the set state. Okay? In the not set state, there is no associated value because it's not set. Okay? Now, what does it look like to declare an optional? Well, let's go back with our option key and take a look at CurrentTitle. Okay, remember this from the documentation? It said var CurrentTitle string question mark. That means this is an optional whose associated value is a string. Okay? So if someone looks at this property and says, what type is that property? And they say, oh, it's a string, but it's optional. No. This is an optional. and its associated value is a string. Okay? Get used to saying this type is optional. Okay? So this is an optional string. That's what we would say. It's an optional string. Okay? But primarily, it's an optional. Okay? Its associated value is a string. So this CurrentTitle, why is it an optional? Well, because we might have a button here that has no title set, not set. Okay? So the title needs to be an optional so it can represent the case where it's not set. Now, anything can be an optional, not just pointers or objects. Ints could be optional. You have an optional int. Okay? But here we are representing the title, the button, which is a string. Okay? And it might be not set. Okay? So we need that to be an optional. So how do I get the string? Because I don't want this digit, which currently is also an optional string. Isn't it kind of weird here when I said let digit equal, nobody said, how come you didn't say :string? Okay? I didn't say the type. I declared a local variable. It didn't even have a type. How was that possible? In Swift, Swift will infer the type all the time. Okay? If it's possible for it to know the type, it will infer it. And in fact, it's wrong, really bad coding style, to put that type in there. It's better to just say let digit equal and let Swift infer it. And here Swift has inferred that digit must be of type string ? That's because this is of type string ? So of course the digit has to be that. You see what's happening there? So you're going to see type inference all the time in Swift. It makes your code much more compact, a lot less repeated stuff. Is that a question in the back?
Is that the same for var too?
It's a question, is that the same for var too? Absolutely, it's the same for var. Okay? So how do I get that string though? If this button title is set, how do I get that associated value thing, okay, out of this optional? And the answer is you put an exclamation point in the end. Okay? Now, optional is ? on the end of a declaration. Exclamation point is unwrap this thing and give me the associated value. Okay? So this is very succinct. Okay? One character for each side of it using this. Okay? Question?
Can you briefly talk about why you want the title to, why you designed title to be optional instead of like an empty string or something if it's not?
Okay, so the question is, why does Swift have this optional thing instead of just doing empty string to mean a button without a title? Or maybe for an int, -1, I don't know, or for a pointer, 0 memory address or something like that. The main reason for that is, for example, pointers to objects in Swift, you don't see the memory address. So you couldn't have it be 0. Okay? That's hidden from you. So there'd be no way to do it. For an int, if you wanted an optional int, is it -1 or 0? Max int? What is it? I don't know what it is. So Swift is trying to be consistent across all things, ints, pointers to objects, whatever, to make sure that we can tell which ones are not set. Okay, so that's the thought behind it. It's really great, actually. Once you get used to it, it's fantastic. All right, so we unwrap it with this exclamation point. Now, what would happen if that CurrentTitle value was not set, and this exclamation point tried to pull out the associated value? What do you think would happen? Error? Yeah, bad error. It would crash my app. Okay? So exclamation point crashes your app if you try to unwrap an optional that's in the not set state, okay, if it's nil. Now, some of you conservative folks might be saying, I'm never using an exclamation point. That's so easy to crash my app, okay? And the answer to that is yes, it is, but sometimes crashing your app is a good thing. It helps you find a bug, okay, because something that you expect to be set by a certain point isn't, and it crashes your app, and you find it before it goes out to your customer, and some unexpected thing is happening because something's not set. Now, I'm going to show you a little later how you can unwrap the optional and get the associated value without crashing. Basically, test to see if it's set and do it. Okay, so I'll show you that in a little bit. All right, so we've unwrapped this optional. We're going to crash if it's not set. That's fine. And so now, notice when I do the option click on digit, what's the type? String, not optional string. String. That's good because we unwrapped it. So now when we run, instead of saying touched optional 6 digit down there, it's going to say touch the 6 digit, touch 2, touch 4, 8, 9. Okay? Got it? Okay. Now, this is going good. But we don't really want this to be printing out in the console. We want our calculator to have a display, and we want the digits we type to go in the display, right? So let's go do that. Let's add a display to our user interface here. We're going to put it at the top. Okay, I'm talking about this thing right up here where this 0 is, and I want it to kind of look similar to that, maybe some different colors, but kind of like that. So I'm going to go back to my utilities area over here and go to the bottom. And this time, instead of grabbing a button, I'm going to grab one of these, a label. So a label is read-only text. Okay? The user can't touch on it and then type with the little keyboard on the iPhone. Okay? This is read-only text, which is what we want in my calculator. So I'm going to bring it over here and bring it out. Again, same way as before. I can resize it. I can change what's in there. I can change the font over here. Let's make this one really big. How about 40 point? I can even make it right aligned. You know how in calculators usually the text is on the right, so there's an alignment thing for the label here, so we'll do that. Maybe I want to change the background color for this one too. How about blue? Okay, there's blue. I don't really like black on blue. Here's a color of the text. We'll go white on blue. Okay, so I can basically set it however I want. Okay, got this UI. I could use the blue lines, by the way, to line it up nicely here, but again, not so important because I'm going to do that flexible UI thing on Wednesday, but I could do it. All right, so now how about connecting this to our controller? This is a little different because this is not a case where the user is going to touch this thing and it's going to invoke a method. It's more the other way around. I want to talk to it. Okay, I want to put things in the display. So this is communication coming from the controller to the display instead of from a button to the controller. So we still connect them up in the same way using control and drag, okay, to put something into our controller. But this time, instead of action up here, we're going to do outlet. And what outlet means is, instead of creating a method, create a property, right? An instance variable. Just like CurrentTitle is an instance variable or a property, we're going to have a property here. And this property is going to point to this display for us, so we can access it anytime we want. So I'm going to call this property display, not that, display. Okay, luckily it got the type right here. It didn't say any objects. It's good. It knows it was a UI label. And don't worry about this storage, weak or strong. We'll talk about that next week, so you can just ignore that for now. Okay, so I hit connect, and it creates, instead of creating a method here, it created a property. Now, again, this IB outlet is just something that Xcode puts to put this little circle here, so we can see what it's connected to, so you can ignore that. I told you to ignore weak and strong, so you can ignore that. And so hopefully this is familiar to you. It looks like CurrentTitle. var, this is a property on our controller. Okay, an instance variable if you want to think of it that way. It's called display. Its type is UI label exclamation point. Okay, now what the heck is that? Exclamation point. Okay, I thought exclamation point was unwrapping optionals. Why is there exclamation point here? It makes no sense. And in fact, you can put a question mark here because exclamation point also means optional. It means the same kind of optional as question mark. And I'm going to leave this question mark and I'm going to keep working on this demo and then I'm going to go back and change it to an exclamation point and show you what exclamation point means. Okay, but exclamation point and question mark both mean optional when you're declaring. Okay? So now I have this display. When numbers get touched here, I want to basically append these digits onto whatever's already in the display. Right? So let's go ahead and do that. We can get rid of this print to the console. We don't need to do that anymore. So I'm going to create another local variable, which is also going to be a constant, so it's let. I'm going to call it text currently in display. Okay, so I want to get the text that's that's in this display currently. So I'm going to send a message to display here, right? Display. And the message, we could look it up in the documentation, but the message I want to send is text. Okay, that gives me the text in a display. This is a UI label method. But this is giving me an error. Okay, and the error that it's giving me here is that I have an unwrapped display. You see that display is an optional label? You can't send text to the type optional. Okay, optional doesn't understand the message text. UI label does. So we need to get that associated value of label of display, which is the UI label. And we do that with the exclamation point here. And again, notice it's offering here to fix it. So I'm going to fix it. And I put the exclamation point in there. Now this is a UI label. it's an unwrapped optional UI label, right? This is a UI label, and I'm sending it the message text. Actually, text is a property, just like CurrentTitle is a property on button, text is a property on UI label. And in fact, if I option click on it, you'll see var text is an optional string. Why? Because the UI label might be not set. The text it might not be set. So it also is an option, just like CurrentTitle. So I need to unwrap that as well. Okay? And so now I have a string, which is the string that's in there. Now, you're probably getting tired of these exclamation points, and so am I, and we're going to be able to get rid of them some in a second here, so not to worry. Anyway, I have this text currently in display, so now I'm just going to say that the displays, okay, and I'm unwrapping it, text equals the text that's currently in the display, I'm just hitting tab here, okay, plus the digit that was pressed. Okay, notice that you can use plus to concatenate strings, that's really fun. Okay, some languages allow that, some not, Swift does. Notice also that when I'm setting the value of an optional, remember text here is an optional string, I can set it to be a string, and that means, by definition, set this optional to set and use this as its associated value, right? Now, how do you think I would set this optional to not be set? Anyone know? You would say, set this thing to be nil. Okay? This keyword means optional not set. So that would set this text. It would blank out this text. It would set it to be not set. Okay? So an optional, when you're setting it, you can set it either to nil or to an associated value. Okay? Sound good? So let's run. All right, so hopefully when we press these buttons, it's going to append it onto the end here. So let's try 5. It did it. 8, 9. Although I'm not really a fan of 0 at the beginning there. Okay, that 0 is not really how a calculator would work. Okay, when I press that 5, I'm essentially typing a new number. It would get rid of the 0. So we really need a way to keep track of whether we're in the middle of typing a number or not. Because if we're in the middle of typing a number, we do the append thing. But if we're not in the middle of typing a number, then we just replace whatever's in that display, right? So I'm going to add a new var, okay, a new instance variable, new property, called user is in the middle of typing. Okay? Now you laugh because that seems like a lot of typing, but I will never have to type that again. Okay? Because Xcode is always going to escape complete things for me. So long names like that are actually good. Okay? You want to pick the shortest name that it conveys what you want, but you want your names, as you know in computer science, naming is everything. You want your names to be very, very, very good for the reader to understand what's going on, okay? Now, this user is in the middle of typing is a bool, okay? So I'm giving it its type, bool. It's not an optional bool, it's just a bool, so no question mark here. Okay, it's either true or false. I'm either in the middle of typing or I'm not. Now, as soon as I put that in there, I got an error. You see that error up there? What? That's not fair. I didn't do anything up there. What is that? Let's click it. Class view controller has no initializers. Okay, now you're doing your homework and you're like, what the? That has nothing to do with what I just did. I just typed a var here. What does that mean? Okay, well the reason you're getting that error is because in Swift, all properties, every single one, have to have an initial value. You are not allowed to have any properties that don't have an initial value. Okay? So how do we give this thing an initial value? Well, there's two ways. One, we create an initializer. That's why you're getting this warning. Now, I'm not going to talk about initializers till next week, so we can't do that because I'm not going to talk about it yet. Okay? What's the other way that we can do it? We can just say equals false. Okay? So we just initialize that, and the red error goes away. Woohoo, we're winning. And I know some of you are saying, oh yeah, what about this one? Okay? You didn't initialize that. Okay, that's because optionals are treated specially. They are always automatically initialized to not set. Okay? So this is basically always happening when you have an optional, a var that's an optional. Which makes sense, right? If an optional, it's not set until you set it to something. So it starts out not set. Okay, so that's why it is set. It's set to not set. Okay? All right, so we have this thing. Now we have this. Let's go ahead and use this thing we created. Actually, I'm going to do one more thing here. You see this colon bool? Do we need that? No. Okay, why don't we need that? Because false can only be a bool. So Swift can infer that the type of this is bool. See that? Okay? All right, so we have this user is in the middle of typing. We only want to do this business right here if the user is in the middle of typing. So now we're going to see an if statement. If the user is in the middle of typing, now again, I'm just hitting tab here. Look, mono hands or one hand. If the user is in the middle of typing, then we're going to do this thing. Okay? If the user is not in the middle of typing, then we're going to set the display's text equal to the digit we just typed. Okay, the 5 or whatever. We're going to replace what's in the display. And of course, in either case, the user is definitely now in the middle of typing. Okay, because you just touched a digit, we're clearly in the middle of typing. Now, I'm getting pretty tired of typing display exclamation point all the time. Okay, all the time typing display exclamation point, when in fact I know that that display is pretty much always set. Okay, the only time that this is not set is for a nanosecond when this starts to come on screen before iOS has a chance to wire it up to this UI label. But once it's wired up, it's set forever. And certainly by the time users are touching on digits, the UI is completely on screen and wired up. And so I know that's never going to be nil. Never. Okay, in this code. So why am I forced to type display exclamation point over and over, okay? And the answer is you don't have to, because we're going to go back and change this question mark to be exclamation point. Basically, if you put the exclamation point where you declare it, it says that anyone can use this thing and it'll implicitly unwrap it. Okay, it'll automatically unwrap it. Now, it's still unwrapping it, so if that was nil, it would still crash. Okay, but it allows me to get rid of all of these exclamation points. Okay, because it's implicit that there's an exclamation point on all of them, because instead of putting a question mark here, I put the exclamation point up there. Everyone got that?
Where would it crash this time?
It would crash down here, in this code down here. As soon as you access this, if that were nil, boom, it would be unwrapping it, because it's implicitly unwrapped. And again, if I change this back to a question mark, now I'm going to get all kinds of warnings down here. See, errors because I'm not unwrapping it. But if I put the exclamation point, now I'm implicitly unwrapping it everywhere. Okay, that's called an implicitly unwrapped optional. Very important, makes your code much nicer and easier to read. Okay, so now let's go see if that fixed everything. All right, so now hopefully when we press 5, it'll get rid of the 0. 5, there it is. And this is still working. Okay, so that's good. We're doing great. Our keyboard is basically fully functional at this point. So now we want to add an operation. Now, because of our technical thing, we're running out of time, but I have 30 minutes left. I'm going to add the pi button. Okay, pi is a very simple operation. It's just going to put pi in the display. So let's do that. I'm going to do that by taking the 7 button and copying and pasting it. That's a really bad idea, as you'll see in a moment. But I'm just going to do that and call it pi. Okay. Now, of course, pi is not a digit button. It's an operation. So I'm going to control drag down here to create another action, a different action. This action is perform operation, okay, because pi is an operation. I'm going to have all my operation buttons call perform operation. And of course, I'm not going to forget to change that to UIButton, okay? Either are you in your homework, right? Okay. And here it is. So there's perform operation right there. Okay. In perform operation, I'm going to do the exact same thing that I did at the beginning of touch digit, which is I'm going to ask the sender, which operation are you? So I'm going to let mathematical symbol equal the sender's current title. Now, of course, I want the string, so I could do the exclamation point, okay? But if this were blank, what if I just wanted to ignore that operation press, okay, instead of crashing? Okay, what if it was legal to have that be blank? Okay, I basically want to unwrap only if this is set. So the way you do that is you don't put the exclamation point there. Instead, you put if at the beginning. And what's nice about this is very little typing, but also look how it reads. Okay? If I can let mathematical symbol equal the sender's current title, then I'm going to do something. Okay? So it reads just like English. It's a really nice way to unwrap. So inside this if, this will be a string. It'll be the associated value of current title. Outside of this if, it's not even defined. Mathematical symbol won't even be defined. Okay? Super simple. So here I can just say if the mathematical symbol equals pi, by the way, Alt-P to make pi, Okay? Then I can set my displays. I don't even need the exclamation point anymore. Text equal to pi, which m underbar pi is pi. If we alt-click on this, this is a symbol. See, m underbar pi. It's a double. It's a double precision value of pi. Now, we have an error here. Why do we have an error? Because it says it cannot assign a type double to something that is a string question mark. Right? We know that display text right here is a string question mark, so we can't do that. So how do we convert this double to a string? And the answer is we have to create a new string. Okay? And now you're going to see how to create new instances of objects in Swift. And the answer is you just put the name of the class and then parentheses, and then inside the parentheses you can put anything that the class will allow you to create one of itself with. Okay? And you can have multiple of these. These are the initializers referred to earlier. And string happens to be able to take a double as one of the things that it knows how to create a new string. So this creates a new string, okay, from a double. So the string class knows how to look at a double, turn it into a bunch of characters that are a double. Okay? So we'll run this. Okay, so here we go. This is still working, and if we press pi, we get pi. Oh, we got a problem. Okay, it's not fitting the whole pi, all the digits. We can fix that really easily. I'm going to go back to here, and if we look at the inspector, there's a nice feature in the label called auto shrink, and I'm going to make it so that auto shrinks, but no smaller than 9 points. Okay, that's going to fix that. We only have one more problem. Okay, so this is working. Pi, what's that? Look at that little pi on the end there. And also, look at this. What a mess. So we got two problems there. For some reason, when we press pi, it puts pi on the end. Well, why is that? Okay, that's because, let's look at this little thing. Okay, pi is sending that, right? How about this one? Uh-oh, pi is sending that too. You see, it's sending touch digit and perform operation. That's because I copied and pasted the 7, which sent touch digit, and then I added this one. Okay, now how do we fix that? You fix that by right-clicking on the button. If you right-click on anything in your UI, you'll see all the connections that it has. Very important to understand right-click, okay? So you right-click, and you can see it only has 2 connections here. It's connected to touch digit and to perform operation. So I'm just going to get rid of the touch digit by clicking this. Gone. Now it only does perform operation. Okay? So we fixed that problem where it was putting pi in the end. All right? And the other problem was that when we have the pi and I started typing numbers, it thought I was in the middle of typing a number and it was adding them on. So that's simple. I'm just going to say user is in the middle of typing number equals false. Okay? Whenever we perform an operation, it's going to wipe out what's in my display. So I'm obviously not in the middle of typing a number anymore. And we have a fully functional calculator with one operation. 45 pi 89. Okay? So on Wednesday, we'll pick up with some more, make a more powerful calculator. Sorry to run over a little bit because of technical difficulties. See you then.
For more, please visit us at stanford.edu.